Hello and welcome to Excellent Link Academy. For this class, we look at the study of calculus. We look at yet a concept called differentiation. By definition, differentiation has to do with the change in a parameter or variable with respect to another parameter or variable. So the change in a parameter or variable with respect to another parameter or variable, that's simply the concept of differentiation. By illustration, let's say I have y, right, to be equal to f of x, right? So my first derivative here becomes dy over dx, which is equal to f prime of x. So here is the concept. If I have y to be equal to x, so it means that the change in y with respect to x becomes the y over the x. That's just the concept. So the change in a parameter or variable with respect to another parameter x or variable, that becomes differentiation. So here's the concept. Let's say I have p to be equal to t. The change in p with respect to t becomes the p over the t. Observe in this first case here, I had y. So y is changing with respect to x. So in that case, I'll have the y over the x. Similarly, p is changing with respect to t. Of course, I'll have the p over the t. Let's say, for instance, I have f to be equal to g. In this case, f is changing with respect to g. Of course, I'll have the f over the g. So the change in a parameter or variable with respect to another parameter or variable, that's just simply the concept of differentiation. When it comes to differentiation, there are several methods involved. We look at this method one after the other. Basically, let's look at the concept of methods of differentiation. Let's look at the methods of differentiation. There are close to 5 methods, right, involved in differentiation. Let's list them out and then look at them one after the other. So the first one there is called the general method, right? So some people call it the power method. If you want to, you call it the general method or the power method. So that's the first method. Number 2, that's called the first principle method, right? Number 3 is called the chain rule method. So either I call it chain rule method or function of a function or function of several functions. So chain rule is called function of a function or function of several functions, right? So I have general method, first principle, chain rule. Number 4, I have product rule, right? Number 5, I have quotient rule, and number 6 there I have implicit differentiation. Implicit differentiation. So these are like these perhaps 6 methods involved in solving problems under differentiation, ranging from general method, first principle, chain rule, product rule, quotient rule, and also implicit differentiation. Let's discuss these methods one after the other. For this video class, we'll look at the first one called general method. In other videos, right, I'll be making in the YouTube page, you'll be seeing this other video for the other methods there. Let's start with the first one called the general method. All right, let's look at general method of differentiation. All right, when it comes to general method of differentiation, there's a keyword you need to be familiar with, right? So note this keyword. Whenever it comes to general method of differentiation, the keyword there is that multiply by the power and subtract 1 from the power. That's all. So the key idea to note when it comes to general method is that you are multiplying by the power and subtracting 1 from the power. For instance, let's say that I have that y is equal to x. For instance, right, y is equal to x. Perhaps let's use a variable aside from x. Let's use, okay, x to the power n per se. Let's say that y is equal to x to the power n. I'm trying to find the y over the x. It's quite easy task to do, right? So here's the thing. If I have y changing with respect to x, that becomes what? Dy over dx has been equal to, we said for general method, the task is quite simple, as multiply by the power and subtract 1 from the power. That's all. What's the power here? The power here is just n. So I'm having n times x to power n, then what? Subtract 1 from the power. It's quite easy. Write out the power. I'm saying multiply by the power and what? Subtract 1 from the power, as in this case. As easy as that. So the key concept to note is to multiply by the power and subtract 1 from the power. That's all. From here, dy over the x here will be equal in value to nx to power n minus 1 after differentiating this given expression. So I'm saying again that the key word to note when it comes to general method is that multiply the power and then subtract 1 from the power, as easy as that. Let's take 3 problems and let's see how we can possibly evaluate those problems using the idea or the key concepts of general method. Example 1. Let's say I have that y is equal to s cubed and I'm asked to find the y over the x. It's easy. I'm seeing y and x, so becomes the change in y with respect to x becomes what there? The y over the x. We just established now that if I have a power, for this case here, I applied general method key concept. What was the key concept? You said multiply by the power. What's the power here? 3. That becomes 3 times, repeat the question, x to power 3. Then we said subtract 1. Multiply by the power and subtract 1 from the power, as easy as that. What next here? If I'm to proceed with solving here, I'll have that dy over the x here is equal in value to, this is 3, this becomes 3 multiplied by, this is x, I have x, but mind you, this is 3 minus 1. Of course, 3 minus 1 will give 2. So I'll have 2 here, and I can call it square in this case. From here, multiply the 2, I'll have that the y over the x is equal to what there? 3x squared. If I differentiate x cubed, I'll end up having 3x squared. This is how to differentiate using general method. Multiply by the power and subtract 1 from the power. Let's take yet another example and let's see how we can possibly evaluate the example. Right, example 2. Let's say I have that y is equal to, let's make it more complex now in this case. Let's say I have 3x to the power 3 minus 2x squared plus 4x minus 5. Let's say I'm asked to find the y over the x here. Basically, I'm seeing y, I'm seeing x is here, several x. So it becomes, I'm representing y with respect to x. That's the concept. So we said that I'm representing y with respect to x. That becomes what? The y over the x. Now I'm seeing 3x cubed, a term. I'm seeing 2x squared, a term on its own. I'm seeing 4x, a term on its own. And I'm seeing 5. Let's differentiate each term one after the other. If I'm seeing 3x cubed, we said the key concept is that what's the power here? 3. We said multiply by the power, that becomes 3. This 3 first times, all the question here was 3x cubed. We said subtract 1 from the power. So I have this. So I'm done evaluating 3x cubed. Move to the next one. I have a minus sign, minus. What's the power here? The power there is 2, becomes 2 times, what's the question here? 2x squared. We said subtract 1 from the power, as established earlier before now. Also, this is a plus sign here, plus. I'm having 4x. If I have a 4x this way, what's the power above x here? Of course, there's an invisible 1 from the power there. So there's an invisible 1 here. So let me just attach it here. There's an invisible 1 there. So whenever a term stand alone, the power is always raised to power. Is always raised to 1. Right? So the power here is 1. That becomes 1 times everything here is what? 4x to power what? This is 1. Then we say subtract 1 minus 1. Right? So the power here is 1. It becomes 1 times what I'm having here. Then subtract 1 from the power. Finally, I can see minus 5. It becomes minus. This is 5. Becomes 0. Why is 5 0? Note that when it comes to differentiation, 5 here is assumed as a constant term. A constant term is simply a term that does not have x. This 5 now does not have x. It refers to as a constant term. So whenever you differentiate a constant term, it's always 0. Please note that whenever you differentiate a constant term, it's always 0. If I differentiate 5 here, I'll have 0. So I have it. So this becomes your concept here. Now you want to ask me that why is it that if I differentiate constant term, I'll have 0? Here's the easy proof to that. Basically, this is 5, right? This is 5 on its own, right? The question here is that is s attached to 5? Of course, you tell me no because I'm not seeing x here. But I can tell you that x is actually attached to 5. How? If I have x to power 0. X to power 0 is of course 1. Because we said from the index law, from the indices concept, we said any number or variable raised to power 0 is equal to 1 except 0. So if I'm having x to power 0, it's just 1. So 1 times 5 will give you 5. So I can express 5 as in terms of what? X. So I'm saying that I can express 5 in terms of x, as in this case. If I'm to apply my normal general method here, we said what's the power here? 0 times what? 5x. This becomes what then? 0. So this is a quick proof that if I differentiate the constant term, I'll have 0. Alright, let's get this done please. From here, I'll have that the y over the x is equal to 3 times 3 gives 9. Next up, x to power 3 minus 1 is 2. This minus, this is 4x all to power 1. So per se, I don't need to start writing now 1 here. I know that if I ignore this 1, there's an invisible 1 there. So I have that. This is a plus sign, plus 1 times 4 is 4. This is x. 1 minus 1 is of course 0. Next up, minus 0. Obviously, from this point here, I can insert something here. This is x to power 0. And we said any variable or number or term x to power 0 is 1. From here, I have that the y over the x here is equal to 9x squared minus 4x plus 4 into 1. Any variable x to power 0 is 1. Minus 0 is off. From here, my final answer for the y over the x here should be equal to, so the y over the x here should be equal to 9x squared minus 4x plus 4. This is my answer after differentiating this question. This comes out to solve problem using general method of differentiation. So if you found this class helpful, do well to like the video, leave a comment, share to your friends and classmates so they can learn too, and also do well to subscribe to my channel for better notification. To see you in the next class, and welcome to Excellent Link Academy.